Alright guys, let's start 10.3. This whole section's on chords. Your essential question today is how are chords related to their central angles and intercepted arcs? At the end of this, you'll be able to relate the length of a chord to its central angle and the arc it intercepts. Here is your central angle Q. So SQ and QR are radii, and RS is a chord. It's part of the intercepted arc, and it connects the two radii together. That's what a chord is. The question here, just for review, why is RS congruent to UT? Well, RS and UT are congruent because the radii that form them or have endpoints in common with them are congruent, and by the reflexive property, the central angle is congruent on both sides. So we have a side angle side situation and a side angle side situation. So these triangles are congruent. So these line segments are also congruent. Alright. So the Theorem 10.3 says if two chords in a circle or in congruent circles are congruent, then their central angles are congruent. So all that's really telling us is if we're given line segment MN is congruent to PQ and they're inside the same circle, their central angles are congruent. So NTM and PTQ are congruent because their chords are congruent. Again, that goes right back to what we just said here. If the radii are congruent and this side is congruent to this side as it's given us, then we have a side congruency. So then, because these are congruent, their angle measures are also congruent for their corresponding parts. Because corresponding parts of congruent triangles are congruent, so these two angles are also congruent. And we just have a side proof here. Let me show you the side proof one more time. TN is congruent to TM because they're both radii. TP and TQ are also both congruent to each other because they're radii. Now if we're going to assume that MN and PQ are congruent, then we do have side congruency, and CPTCC does tell us that these are in fact congruent by side. Converse, as you guys know by this point, we're going to skip over for the most part. It's just the flip, right? Alright. Here's Theorem 10.5. If chords are equidistant, meaning the same distance from the center of a circle or the centers of congruent circles, then they are congruent. So here's our circle with center at S, and it's saying that SE and SF are congruent because they're the exact same, or sorry, AB and DC are congruent because SF and SE are congruent. This one is greatly important. This is one of the most important ones that we're going to learn here. This is the one that you're going to want to know when you go to sit for the SAT. This question's going to be on there most likely. It's in all the SAT review books. It's everywhere. So let me take this one over really quick and actually just talk about it really quick, even though it does seem pretty. Okay, so one more time we'll read it. If chords are equidistant, same distance from the center of a circle or the centers of congruent circles, then they are congruent. So here's some preview on your homework problems, but let's just look at this one really quick. Come on, buddy. There you go. All right. So really quick, that's upside down. So we have SE is congruent to SF as it's given us. That's these orange lines. So let's say if I were to define that to be 5, this would also be 5. And because these are congruent in length and they meet at 90 degrees to the chord, AB and DC are congruent. So if I were to say the length of AB is 12, then I know the length of DC is also 12. That's pretty much all that one's showing. This is not really a hard topic. You're going to see how easy the homework is. It's actually kind of funny how easy it is considering how hard 10.1 was. 10.2 was much easier, and it just keeps on a trend till into 10.3. Alright, so our 10.6 or a 10-6 theorem is if a diameter is perpendicular to a chord, then it bisects the chord. All that's saying is if I draw a chord that's a line that starts and ends somewhere on the circumference, alright, if it's perpendicular to the diameter, which is cutting the circle in half, then the diameter cuts it in half. Again, pretty easy stuff, right? Here's our diameter. Here's our chord in blue. Our chord and diameter meet at 90 degrees. That means our blue line is cut in half by our dotted line. The perpendicular bisector of a chord contains the center of the circle. So look here. Look here. Part of 10.6 says if the diameter is perpendicular. And here it says the perpendicular bisector. If the diameter is perpendicular, it's a bisector, right? So setting this one up, 10.6, we have a diameter that bisects the chord because it is perpendicular. This is exactly the same thing, just worded differently. This time it's telling us, so it's kind of the backwards version. The perpendicular bisector of a chord contains the center. There is no way to bisect a chord. Again, that's the blue line. It has a start point and an end point on the circumference. If we are going to bisect that at 90 degrees, that line that bisects it must pass through the center. Here's our concept summary. I have 2 of your homework problems to go back to on Smooth Draw to go over. Go ahead and pause the video here. Usually I'd ask you to pause the video a few more times, but this really is a quick, easy one to get over. So let's switch over now. Okay. So in circle O, so here's O, that's our center. AB is congruent to CD, so let's mark that up. Now notice I'm marking the line segments because we don't have an arc here. That is showing me that these are line segments. Alright. Also, the center of the circle, point O, is the intersection of CD and AD. So, CB and AD. So it meets, both lines cross at the center of the circle. Now wants to know what, we know arc BD is 130 degrees. What is the measure of angle 4? So let's get rid of that circle here. Okay, so it wants to know what is this angle right here. Well, what's our radius here? Has a radius been given? No, we don't have a length of the radius. So we can assume r equals 1. And that's going to help us immensely, right? If no length is given for the diameter or the radius, right? Because if we have the diameter, we can find the radius. If there is no length given, just like in 10.1, we're automatically going to assume a radius of 1. Well, what do we know now about arc length and central angle measure when the radius is equal 1? Yeah. If you remember that they are equivalent, then we know that the measure of angle 4 is 130 degrees. It's actually a really easy problem. They just threw a lot at you to go for it. And here you go. Now, yeah, no, there's no other way to go over that. That won't be more confusing. So, all right, let's find the value of x. We need the value of this chord right here. Now we have a couple things going on here from the lesson we just covered. It was nice enough to tell us that this and this are congruent, so I can go ahead and say that this side is also 7. But I need to know, let's call this A, B. It's really asking me to find what is the length of line segment AB. Well, let's go back to our PowerPoint really quick and then we'll be done with this. Alright, If SE is congruent to SF, that's the two lines here, from the center to the chord, then AB and CD, and that's backwards, are congruent. So let's see here. Are these congruent? Well, we have a length of 8 here and here. Since those are congruent, these are also congruent. This line and this line. So let's call this C. So now we know that AB is congruent to CB. So if CB is 14, then AB is 14. It's a pretty easy topic. Nice and short video this week. I'm going to go ahead and stop it here. Homework is already assigned on Pearson. It's not due until the 11th if you're watching this in 2020. The 11th of April at 11:59. Pearson seems to be much more stable over the weekend. That could just be because not as many people are trying to use the website. We'll keep an eye on it this week, and if it stays stable throughout the week, we'll go back to the old, do the next day after class at 11:59 instead of giving you until Saturday at 11:59. But if you're having trouble, do not hesitate to let me know you're having trouble with Pearson so we can keep an eye on it.